Next step is you have to calculate the effective load. So step 4 will be calculation of effective load. So by preliminary estimation you can calculate effective load. P effective as CA CMPT divided by CV. Okay, so by using this formula you can calculate P effective. Now here CA is application factor that is given, CM is load distribution factor, and PT is nothing but the tangential force. So tangential force you will get from power by velocity. Okay, and again CV you will get, the formula of CV is already given in the example. Okay, so formula of CV is 6 divided by 6 plus V, it is given. Okay. So you have to use this formula only, 6 divided by 6 plus V. So here in both the cases you need velocity, and velocity is nothing but pitch line velocity. You will get velocity as pi dn divided by 16 to 1000. Now here you can take pi dp np, or you can go for pi dg ng. So here what you need is dp and np. Okay, so to calculate dp and np again, so to calculate dp we need module as well as number of teeth. Okay, so here we will write here, so dp is equal to what, m into zp. Now here m we don't know, zp we have, zp is 20. Okay, so you can write here dp is 20 m. Now np is given, so your velocity will be pi into 20 m into np is given as 1440 rpm divided by 16 to 1000. Okay, so if you calculate all this, so you will get velocity as 1.508 module in meter per second. Now next is pt. Pt is nothing but tangential force, and it is power by velocity. So power is nothing but here 20 into 10 raised to 3 divided by velocity is 1.508 module. So you will get pt 13262.6 divided by module in Newton. Then after getting PT you need to go for CV. So CV is equal to 6 divided by 6 plus V. So 6 divided by 6 plus, now V is 1.508 module. Okay, so now we cannot solve it, so we will leave it as it is, your CV. Now if we substitute all these values in the formula of P effective, so your P effective is equal to CA CM PT divided by CV. Now CA is nothing but application factor, and application factor is given as 1.45. CM is 1.4, it is also given, and 2 into PT. PT is nothing but we are having PT in terms of module. So 13262.6 divided by module divided by CV. So again CV we are having in terms of module. Okay, now if you simplify it, so you can write this P effective like this, 1.5 into 1.4 into 13262.6 into, now this denominator will come in numerator, 6 plus 1.508 module. Okay, now divided by this denominator and this denominator. Okay, 6 m. Okay. So now you can solve this 1.5 into 1.4 into this into divided by 6. Okay, so you will get P effective is equal to, the value is 4641.91 in bracket 6 plus 1.508 module divided by module. Okay, so this will the simplified value of P effective, because we don't have module, so you cannot solve it further. Then after that you have to equate this module. Okay, so your next step will be step 5. Step 5 will be, you have to equate strength with factor of safety into P effective. Now strength will be the lower strength, okay, whichever is lower, either it is beam strength or wear strength. So now in this case wear strength is smaller than beam strength, so we have to equate wear strength with factor of safety into P effective. Okay, So here wear strength is given as 664 point, wear strength we have calculated 664.09 module square is equal to, now factor of safety is given 1.35 into p factor just we have calculated 4641.91 in bracket 6 plus 1.508 module divided by module. Okay, now you can simplify this equation. This module will come here, this module square is there, so module into module square will become module cube. This 664.09 will come in here in denominator, and this bracket will leave as it is, or you can open the bracket also. Okay, 1.3 into this into 6, and similarly this outer part into this one. Okay, so after simplifying this equation you will get module cube is equal to 56.618 plus 14.23 module. Okay, so this is the simplified equation. Then after that you can use this your calculator to solve this equation easily. Okay, so after solving, if you will face any problem in solving, you can ask me okay later. So module is equal to, after solving with the help of calculator, module will be 5.1 mm. Okay, now after getting the value of module, you need to select the next standard value of module. Okay, so here selecting next standard value of module as, now after 5.1 the next standard value is 6 mm. Okay, so 6 mm will be your next standard value of module. Now after getting the value of module, you need to find the dimensions of the gear pair. So your next step 6 will be dimensions of the gear pair.